Okay, perfect. So hi everyone, and a warm welcome back to the start of a new academic year and a new term here at CDRN, the Cambridge Disaster Research Network. I think I know most of you, but for those who I haven't met before, my name is Ainsley Trahan, and I'm one of the co-conveners of CDRN and also a fourth-year PhD student in geography here at Cambridge, studying the geology of post-Soviet disaster risk reduction. And I'm joined by my co-conveners, Farah, Joshua, Kasumika, and Julie, who we will be hearing from today. So we're really thrilled to have Julie kick off to give the first talk of the term. And so as I've mentioned, Julie Morin is one of the co-conveners here at CDRN, and she's also a postdoctoral research associate here in the Department of Geography at Cambridge. She is a geographer with a transdisciplinary expertise in disaster risk reduction and crisis management, focusing especially in island and volcanic environments. She's currently researching social volcanology on the ERC project Imagine, where she works with communities, authorities, and scientists to understand cultures and knowledge in volcanic areas through participatory approaches. And we're really, really excited to be hearing from her today about some of her work in engaging communities in disaster research, where she'll be pulling from a case study in Chaitén, Chile. So I will hand over to Julie. And just for those who haven't joined us previously, Julie will give her presentation, and then we will have time for Q&A at the end and discussion. So yes, thank you.
Thanks a lot, Ainsley. Yes, can you hear me properly? Yeah, thanks a lot, Ainsley, and hello and welcome everyone. Thanks a lot for coming to our CDRN sessions. So I'm gonna talk to you today about a project we led in Chaitén, in Chile, with a number of collaborators from the University of Cambridge, but also from the Chilean Geological Survey, the Chaitén community and authorities, including 2 local museums and New York University. As Ainsley told you, if I can change, as Ainsley told you, it's part of the project I'm presenting today is part of a broader project funded by the European Research Council called Imagine, led by Professor Amy Donovan at Cambridge, in which we explore how different types of knowledge are about the environment, and particularly about risk, disaster risk, how this knowledge is constructed, exchanged, negotiated by different groups, and how these different types of knowledge can be combined with each other to propose effective disaster risk reduction options, given that many times these different groups have very diverse perceptions of the environment, as you can see on these little pictures. So the idea is notably to be able to combine scientific and local knowledge. And the project has been led on 15 different sites in 4 countries that I'm not going to detail, but in Central and South America. And today we're going to focus on one of the case studies, which is the place where we formally developed the methodologies, which is Chaitén in southern Chile. So Chaitén, first, is a small town, about 4,000 inhabitants in 2025. It's a coastal town, which is a tourist transit point. It's considered as the gateway to Patagonia. It's quite isolated territory with a limited access with only sea routes and one land route leading to southern Chile and Argentina. And historically, its economy was based on agriculture and fishery. It's located in between 3 volcanoes. I'm gonna try to get the laser. So Chaitén volcano, Michin Mahuida, and Corcovado volcano. And the volcano which will be of interest to us today is specifically Chaitén volcano, that is located by the red arrow in Chaitén town, and which is located just 10 kilometers away from the town, and is considered in the new risk ranking for Chilean volcanoes as the seventh most dangerous volcano over the few hundred volcanoes they have in Chile. And you can see on the picture, on the bottom picture, the domes that are formed after the last eruption, the lava domes in the caldera of the volcano. It became sadly infamous in 2008. Before that, Chaitén was relatively unknown, as well as Chaitén volcano. As on May 2nd, 2008, the volcano erupted and presented a massive eruptive column for over 2 weeks. So a Plinian to subplinian eruption with the eruptive column reaching 20 kilometers in height. And with one very major concern, which was if this eruptive column collapses, it might trigger pyroclastic flows up to Chaitén town. Fortunately, the eruptive column remained sustained, and it was dispersed towards the northeast, and so it didn't collapse, and the ash spread and the deposit spread mainly towards east and not directly on Chaitén town, even so you can see on the central picture that it was badly affected. When the eruption started, the whole Chaitén was evacuated in less than 2 days. It was a compulsory evacuation, and we can come back on this later, which is still very poorly considered by the Chaitén inhabitants. They have very bad feelings about this forced evacuation. And after they were evacuated, from May 11, lahars started, so volcanic mud flows, started to flow down from the volcano into the Rio Blanco towards Chaitén town, and completely washed over the town. And the Rio Blanco, so the river flowing from the volcano to the town, literally split Chaitén in two. There was an avulsion of the river, which used to go the riverbed used to be the yellow line that you can see on these pictures. And because of the lahars and this avulsion, the riverbed completely changed. So this is now the red arrow, and split Chaitén in two. And Chaitén was declared inhabitable by the authorities. So you can see the same effects on pre and post disaster with satellite image, with a drastic change in Chaitén. And because it was declared inhabitable, the government proposed to fully rebuild a new Chaitén in a locality further north in Santa Barbara. But the inhabitants were did absolutely not agree with this. They were completely against this relocation, and they started to come back to Chaitén progressively despite the interdiction. They came back, and it was such a problem, and the relocation met such a strong opposition that the authorities had to reconsider the fact that Chaitén might or might not be inhabitable. And they started to propose plans from 2011 where the northern part of Chaitén would be considered habitable, like you could have basic services and housing, but the whole of Chaitén, like most of Chaitén, would stay an exclusion zone for urban development. The reality is that progressively people continued to come back. And today, basically, the whole Chaitén is inhabited again. Even so, the southern Chaitén, so the southern part to the south of the river, suffers basic lack of, not a basic lack, a lack of basic services. And 4,000 inhabitants have resettled now in the city, in the town, sorry. This is a main problem. If you take a look at the hazard map, which was produced by the Chilean Geological Survey in 2015, the volcano is located here. The Rio Blanco, so the river, is located here, and here is Chaitén town. And it's in the dark red area. And when you take a look at the legend of the dark red area, it's very high hazard that may be affected by lahars and pyroclastic flows regardless of the eruption's magnitude. So any eruption might directly impact Chaitén town. And we know, on top of that, that much bigger eruptions in the geological records have occurred, much bigger than 2008, with major explosive events 10,000 and 5,000 years ago, and a sort of similar eruption to the 2008 in the mid-17th century. And finally, in Chaitén, after the 2008 disaster, they inaugurated Museo de Sitio, so a local museum, whose aim is to commemorate the disaster. So it was really created to maintain the memory of the events. It was created along the river on a parcel where you have a brand new building with an exhibition room, but you also have partly destroyed houses which were maintained to maintain the memory of the disaster. So the Chaitén Museum is this combo, this mix of new edifice with exhibition rooms and partly destroyed former Chaitén. Now, in the framework of the project, because I had a weird message saying all done. Ainsley?
Julie, can you hear us? Can you hear me?
Yes, now I can hear you. I had a weird message on my whole screen saying all done. The thing is interrupted.
I think there may have been an issue with the internet, but we can hear you now, though.
Okay, sorry. So I was saying that we had this initial fieldwork in the framework of the Imagine project in November 2021 in Chaitén, during which we made mainly interviews, 36 qualitative interviews and participant and passive observations. And I'm gonna just give you a few insights of the main findings during this first Chaitén fieldwork. And it explains how and why we decided to develop and to engage with the community in the later steps of the project. So the first aspect during these interviews in this fieldwork was considerable pain to have a visual engagement with the landscape because of adverse weather conditions. So Chaitén is in Patagonia. On my presentation, I've put mainly pictures where you can see something when it's sunny, but the weather is most of the time complex, and it's very difficult for interviewees to relate to the landscape because of this weather. And sometimes, even when the weather is really beautiful, is the case with this woman, Celinda, who is pointing at something very far away in the landscape. And for us as researchers, it's extremely complex to be sure that we're able to spatially correctly contextualize in the landscape and in the territory what the interviewee is saying. So that was the first global observation, which might be applicable to many different territories. Then there are the observations directly coming from the analysis of the interviews, with Chaitén community members describing a high fatigue due to being an over-researched community, but coming into contrast with a fundamental need to still speak about the 2008 events, which remain very deeply traumatic to them. So it was a bit contrasted, and they said we're fed up to talk, but we need to talk, which led us as researchers to think that we should find different ways to engage with them. Then many interviewees describe scientific extractivism and say that so many research teams came, gather, collect the data, say they will share the results, and disappear forever without having shared anything. And it was almost every interview started with interviewee raising that point and saying, you will be just another researcher having my time and not providing anything back in return. And then more in terms of the analysis, not what they say directly, but what we were able to observe based on content analysis. There is unfortunately very limited volcanic hazard awareness. I'm going to come back on this in 1 minute, but coming with a high demand for geological information. So now just a few words about this limited volcanic hazard awareness, which is fundamental in Chaitén. First, because of the events, there have been major demographic changes, with many of the new, many of the 4,000 inhabitants who came back, who are newcomers. So like maybe half of the former inhabitants came back, and newcomers came. And for sure, you have kids who never experienced the 2008 eruption or were too small to remember, too young to remember. So you have like a big portion of Chaitén inhabitants who have not the experience of the 2008 events. Then the residents consider that the 2008 eruption lasted 2 weeks. And so it's feeding the idea that the prolonged evacuation and the government trying to prohibit the return to Chaitén was politically and economically driven, and it had nothing to do with the hazard aspects. While the eruption in reality lasted for 20 months, with the lava dome you saw in one of the first pictures, the lava dome growing into the volcano and partially collapsing during these 20 months, with some pyroclastic flows mostly like practically reaching Chaitén town. Then what we observed is that the hazard awareness is mainly limited to lahars and ashfall, and that these pyroclastic flows, which are a main problem potentially, are something that people do not have in mind. And finally, something that has been central in one of the projects we have developed, there is a belief that the 2000 event was a unique one-off event, and that the volcano did its thing. Like it's done, it was once in history, and it won't happen again. For sure, there are discrepancies between what people think in the community, but that was expressed by most of the interviewers. And finally, the interactions during this fieldwork led to the understanding that the local museum was formally requiring support to produce scientific content for the exhibition room. And you can see this was on the picture, the state of the exhibition room the first time we went there. So just a few panels with a few testimonies, but the museum was very empty at that time. So now wrapping up all these things, the community needs and concerns, the museum needs, the awareness gap, and our need as a researcher to find modes of visual engagement with the landscape. We proposed a methodology to the community called Volcano Voices. And the community immediately validated this methodology, because we presented it as a way to practice ethical research with shared outcomes which would be defined by the community itself, the project would aim at fostering risk awareness, allow a dialogue between the local and scientific knowledge, and be co-produced with the community, which allows to address the shortcomings of the knowledge deficit model. Because since the beginning, I'm saying that hazard awareness was low. It's keeping in mind that the knowledge deficit model can be problematic when we talk about disaster risk reduction. We can come back on this later. So what is Volcano Voices? So this is a map hosted on the Department of Geography webpage, in which you have icons that you can click on with a description of the different icons on the main map. And so you can click on the icon and you arrive in a full 360 degree picture in which contents are embedded. This is called Volcano Voices, and in the case of Chaitén, it's called Voces de Chaitén, so Voices of Chaitén. It's voices because the main contents are essentially audio. But we also have other types of contents, as you will see later. So Volcano Voices is the project, so it's the final map. It's an interactive map, but it's also the methodology we developed with the community. So during the semi-structured interviews, the 36 semi-structured interviews during the first phase of the project, we validated the principle of Volcano Voices with the community, and the community members created their own map of the places of importance to them in Chaitén. So they defined the places that they would like to have on their interactive map in Chaitén. And we drew it together by hand. So it's looking like very childish, but it was extremely efficient because visually each point on the map is immediately identifiable by the community members. Once it was done, we went to each place and took 360 pictures, either with a tablet grounded or with a drone. And with these pictures that we embedded on the map, we came back to the community and we made specific map-based interviews focusing very specifically on these different places which they had predefined. So this was the next year. Once we had the contents, like the 360-degree pictures and the contents from like collected during these specific interviews, we used a tool called Marzipano, which is a free tool online. You import the 360 images, and once you have imported the picture, you just embed hotspots and the contents of these hotspots. And you can embed other types like links to other images. And so you can see that you can have different environments in Marzipano. And once you have embedded your hotspots, which will become the future content which is embedded on the Volcano Voices map, you export everything. And there is a code which has been made available online, which allows to import the Marzipano export to your website and to create the map with the contents. Hopefully it's clear. If not, I can respond to questions later. And so in this map, I said that the audio is the main content, but we also have so the audio first, it's bilingual. So because it was in Chaitén, it's in Spanish, but we always have a short description of what the audio is, and it's duplicated into English. So the audio is only in Spanish, but the text is in English. We have pictures, access to online content, so web contents. We have different levels of knowledge with access sometimes to an expert level for instance, geology students. And we have textual descriptions and direct links to other environments on the map. So there are a set of different contents, and the map is made available online through a permalink, and it's also made, and you can access it either from a computer or phone, from any device, but it's also made available at the Chaitén Museum on tablets, so touch screens, and QR codes, depending on the different sections of the museum. So it's accessible locally and online. Now, the very interesting thing for us was the accuracy of using this methodology to collect deep and meaningful environmental research data. The first aspect is 360-degree images has been so powerful to engage with the communities. The reaction I've put under the picture, how you feel like you were there, it's amazing. That was a common reaction from absolutely everyone. The 360 and really motivating the people to engage with the contents. What we found very useful is that I've put these two little drawings. Basically, as a risk researcher, when you try to do a formal semi-structured interviews, most of the time your interviewees feel like that. They do not feel comfortable. They feel like they are questioned, but it's not necessarily easy for them. And what we realized is that going through this 360-degree environment and process is literally making them feel like that. And the very interesting point is that they feel that they invite you in their territory rather than you inviting them in your interview. And it changes completely the way they relate about things during the interview, and they feel very relaxed about the interview, which is not always the case in other contexts. The other very positive aspect in terms of data collection, is that using these 360 pictures, so for instance, here from it's a drone picture, it allows to relate very precisely to features of the landscape and the territory. So things which would be difficult to identify just talking with the interviewee, when it's a 360-degree image-based interview, you have a visual approach with much more precision in some occasions. Then we realize that it opens the narratives. It's quite incredible. For instance, climate change, it's something very virtual to some extent for the local communities. And well, they could tell you things about climate change, but when they look at the landscape, it becomes a bit complicated and they stay voiceless. And with these pictures, it's interesting because as you can see far away and you can extend your vision of the territory, they were able to relate to climate change, saying like, oh, you see this other mountain behind, before when I was a kid, there was snow on it. And they were starting to engage with some other kind of narratives and most specifically linked to climate change during the interviews. While they would not provide these elements during the classical semi-structured interviews. And finally, these pictures allow for any other aspect of the life in the territory to be considered. So it's not necessarily hazard, but vulnerability aspects, anything cultural, fauna, flora, things which are absolutely not risk-related. And it makes their narratives a bit more holistic, but also more interesting to themselves. Like it's not risk focused, and they're happy to bring a broader image of the territory. And the other thing is that connecting through the map, these 360 pictures together, it gave access to remote places in the territory, which very interestingly allowed to connect different hazard aspects. So for instance, after the Chaitén eruption, there was a massive degradation of the vegetation, which triggered the roots of the trees were weakened, and all over the place started to occur small to big landslides. And like seeing the different environments on the map made them able to relate, to interconnect the different types of hazards and to relate them to the 2008 eruption, while these aspects had not come through the classical semi-structure interviews. And well, finally, for the community in general, so for the community not necessarily involved in the interviews, but accessing the map as a project, it gives access to remote places. So it provides an opportunity to discover more the territory and the memory of other people about their own territory. But also, I told you, I've developed the project in other places. And so they get to know other volcanic territories. And it was very interesting to observe some of the reactions, discovering new places, looking like their own place, but completely different. And in terms of philosophy of the research, the project allows us to value local knowledge to an extent where local and scientific knowledge are provided completely horizontally, with the community deciding of their level of engagement, the content to be put in the map, and to decide how the results will be used. And there was this work with the Chilean Geological Survey, and we asked them if they would like to provide some information on specific information on hazard and risk to respond to some of the narratives provided by the community. And they said, no, we are not responding to anything. There is this local knowledge, and we will provide scientific information, but we're not trying to respond to each other. We just provide the two things in parallel, horizontally, which made the community extremely happy. And I'm gonna use this picture where, so it's in Chaitén, in a remote area of Chaitén, and we are on a land, it's a private land, and the landlord came with us on this path and started to describe the deposits. And it was extremely interesting. He said, you see this layer? I think it comes from Chaitén volcano. And the 2008 Chaitén volcano layer is here, like it's literally a 5 centimeters layer. So the Chaitén volcano produced these considerable Holocene eruptions, as I described at the beginning of the presentation. And he said, if you dig 1 more meter, you will find the exact same layer, even a bit thicker. And because there are these 2 layers, and now there is the same distance between the bottom layer and the middle layer, and now the upper layer, I think it will erupt again in a very strong way sometime soon. So just observing the layers on his land, he was able to relate about the frequency of potential eruptions, and it's corroborated by scientific evidence. So we decided that it was a unique opportunity because we had this set of local knowledge. It was a unique opportunity, and we were wondering if someone could interpret these layers as something giving an information of the eruptive frequency of the Chaitén volcano, should we try to bring these layers to the local museum? And so we started to discuss with the Geological Survey Chilean colleagues. And we found, Yes, because so these layers, I told you, are located in this isolated part of Chaitén. Chaitén Tone is here. Chaitén volcano is here. So Chaitén Tone is here. The deposits you have seen on the previous slide are here. And this is the map of the main winds and hazard map for the deposits. So the deposits are basically taken to the east because of the main winds, which implies that these sort of deposits are not visible within Chaitén Tone. So we decided to find a way to bring them back into Chaitén Tone to raise the hazard awareness about Chaitén events. And we also, so these are Holocene deposits. And as I said at the beginning of the presentation, there has been at least one historical eruption in the mid 17th century. So this is an eruption whose deposits you can find in some parts of Chaitén, but not until now, not in Chaitén Town. And it's been described on a nautical map, which was stolen by the pirate Sir Henry Morgan and retrieved later on. And we started to think, okay, so we have these deposits and we have this wonderful story to engage the community with. So we have to find a way to bring back the deposits to the museum. And we found a way through a methodology based on the use of an epoxy resin. So it's a resin with two components. You have the resin itself, and when you mix it up with the second component with it, which is an hardener, you can paint anything. And when it gets dry, it gets solid. So it forms a plate, a solid plate. And because the volcanic deposits in that area are loose, if you paint the deposit with this resin, by capillarity, the resin is going through the deposits. And when it dries, it gets hard. And you have a plate of deposits that you can take away from fieldwork. So that's how it works. First, we cleaned the different deposits we were interested in. So we cleaned the outcrops. We mixed the resin. And we painted the deposit. And that's how it looks like after being painted and starting to get dry and so to get hard. And when it's completely hard, you take it away from the volcanic hole, from the natural outcrop, and it gives you an amazing replica. Like it's literally your deposits. When you flip it upside down, you have this plate of deposits that you can bring to the museum. So in this case, the upper layer is the Chaitén 2008 eruption. And we thought we had captured the Pirate Morgan eruption below. And it was so disappointing because we realized after taking everything to the museum and starting analysis that it was not. But very interestingly, it's not Pirate Morgan eruption, but it's an eruption which might have been described by Darwin in an account in 1840. It might be an eruption from the other volcano, so the Mission Maweda that we talked about on the first two slides. So the pirate tail was replaced, but still it's sort of sexy, a sexy story to engage in a museum with people just facing deposits. And it came along in the museum with the older deposits, so the Holocene deposits I told you about a bit earlier. So we were able to capture a Plinian eruption of Chaitén, 4,000 years old, and an eruption of the Milchimawida. So all this was presented in the museum. So it's a museum with voluntaries. So it's volunteers, sorry. So it's building progressively. It's very slow. So for now, it's still presented like that. But it gives a good idea to the Chaitén inhabitants about the pattern of frequent and diverse volcanic activity in the area, and to let them know that the 2000 event was not a unique eruption. And it is combined in the museum with the Volcano Voices project through QR code. So you have this plate, you have a QR code leading you back to this environment that we stopped on earlier. And it allows to provide more information, which is not present on the plate, but which is present in the Volcano Voices about other eruptions that you would find on the plate if you were digging a little more, etc. So the two projects have been interconnected, and they create some complementary visual tools to provide to offer information on hazard. It was co-created with the localities, with the communities, to reflect on their local realities, and we hope it will make the content more meaningful and actionable in terms of disaster risk reduction for the community. And the community expressed a mixture of surprise, interest, and pride during and after the completion of the project. And I'm stopping here with links to the two different projects for the people who are interested. Many thanks.
Fabulous. Thank you so much, Julie. That was really interesting, and so great to hear about your hard work over these past few years and the really exciting and innovative methodology that you guys have developed, which is also a product. I'm actually going to go ahead and paste the link to the Volcano Voices project in the chat for anyone who's interested in seeing that interactive map on the Cambridge Geography website. And I'll go ahead and stop the recording as well.
Yes, maybe I can